All right, we're starting our part 2 of the problems for 10.4. So we're on our second worksheet. And I want to take a look at the first question together. This is one of my favorite questions. It's such a classic pop culture idea of this concept that there's so many ways to pick lottery numbers, but now we have the tools to actually answer specifically how many different lottery numbers are possible to pick. So that to pick the right one, you'd have to pick one out of that many total number of ways. So I wrote down the instructions for the Kansas Mega Millions lottery. So if you read on your worksheet, there's a little more than what I wrote up here. It says you get a board with 2 sections. The first section has the numbers 1 through 70, and the second section has the numbers 1 through 25. And what you do is you mark or pick 5 numbers from the section that has the numbers 1 through 70. And then you pick one number from the section that has the numbers 1 through 25. So in total, you end up with 6 numbers. And what we want to know is in how many ways can you select those 6 lottery numbers? Such a fun question. Again, if you haven't tried it yet, try and start this one on your own. Try and think it through. And then restart the video when you're ready to look at the solutions. But I want to start to think through this question together. One of the things that's kind of good to think about is when they list the instructions, trying to think about what does it actually look like that we're doing, right? We're literally going to get like a card or a piece of paper where it's in 2 different sections, and on one part there's the numbers 1 through 70. And then on this other part, it's smaller, and there's only the numbers 1 through 25. So 2 different sections. And what I do on the first section is I pick 5 different numbers from that section. And all I do is actually mark them on the board. So we're literally just going to say cross off this number, and this number, and this number, this number, this number, right? We're going to pick 5 of them. I'm also then going to go to the second section and pick one of those numbers. And I'm going to hand this board in to the people who are working. Now, let's really think about what happens. So if we had to start to break this down, we might think about, okay, for how many events do we have? Do I need 6 events? Do I need 1 for each number? Or do I need something different than that? Well, let's think about, does the order that I pick the numbers in really matter? Is there really a first number, second number, third number? Now, on that first section with the numbers 1 through 70, all I do is I cross off the numbers on the board. Does it really matter if I say cross off this number first, and then this number, then this one, so on and so forth, versus, say, picking this one first, and then this one, and then this one, and so on and so forth? Well, in the end, it doesn't really matter, right? It's just which of the 5 numbers did you pick. So really what we're doing is we've got 2 different sections of the board, right? There's section 1, and then there's section 2. And in section 1, what we do is really, it might not be as natural to use the word, but it still is true, right? We're picking a group. We're picking a group of numbers. All that matters is the collection of numbers that I pick. It doesn't matter the order that I pick them in, at least not in this style of lottery, because literally, all that matters is in the end, what did I cross off on the board? That's all that gets looked at. So we need to pick, well, we're picking 5 numbers. From how many? Well, on that section, that's the numbers 1 through 70, so there's 70 options. Pick 5 numbers from 70 options. Well, how many ways can I do that? Well, again, it's a group. So that means use a combination. So a combination from 70 things, choose 5 things. Now for section 2, all I need to do is pick 1 thing from, well, we have the numbers 1 through 25, so 25 things. Now we could think about that in 2 different ways. You could think about it as a little mini group, so we could have something like a combination from 25 things, choose one. That's a perfectly fine way to do it. And if you simplify that, if you compute what that number would be by using the factorial formula, it comes out to be 25, which makes a lot of sense, right? All I'm doing is picking one thing. It's not necessarily a group per se. It's just, well, there's 25 different things to pick from, and I need to pick one. So there's 25 ways to do it. Either way you do the problem is fine. In the end, you're going to multiply by 25. Because notice with these two events, those two events is sequential counting principle. So in the end, we will multiply them together. Pretty cool. So the big takeaway, right, is we didn't need 6 events. We would have needed 6 events if somehow they said pick 6 numbers where the order that you pick the numbers matters. If I was writing down a list of numbers where, say, picking 10 first and then 70 was different than picking 70 and then 10. In this one, it's not. I just end up crossing off both numbers. So let's try and compute this. Let's do it as side work this time. So for some side work, let's do the combination. So from 70 things, select 5 of them. So that's going to be 70 factorial over 5 factorial times 70 minus 5 quantity factorial. So 70 factorial over 5 factorial, 65 factorial. And I do want you to get in the habit of always kind of writing this out, how we're simplifying it, because it makes a difference to make sure that you're showing all the steps you need to get to the end. So remember, start to write out 70 factorial. Luckily, we don't have to write the whole thing, because that would be really long. So just go 70 times 69 times 68 times 67 times 66, and we think about, well, when am I going to stop? When we hit the larger of the 2 in the bottom, so times 65 factorial, and then this is all over 5 factorial times 65 factorial, so cancel those 65 factorials, so you're left with 70 times 69 times 68 times 67 times 66, all over 5 times 4 times 3 times 2 times 1. Again, notice that little trick to help us remember we've got the same number of numbers on the top and the bottom. It's just a little way to check if you did it right. So then if we multiply those and simplify it out, so I went ahead and did it both. So I took the top and then divided it by 120, and you end up with 121,030,114. So let's see, 12,103,014. So remember, that's just the combination. We still have to come back and put it into sequential counting. So then sequential counting principle, right, we had section 1 and section 2. So section 1 is this 12,103,014. And then section 2 was the 25. And sequential counting says multiply those two numbers together. So multiply that 12 million number times the 25, and you end up with 302,575,000 and 350. Which is a huge, huge, huge number. So about 302.5 million different possible lottery numbers. So to be the ultimate winner, you'd have to be the one correct combination that was chosen. So not only can we now think about, well, yeah, it's hard to win the lottery because there's a lot of ways of picking the numbers. There's that many ways of picking the numbers. So a super, super cool thing that we get to do now. We're going to keep working on problems. We're going to keep trying them and practicing them. So you try them and then hop on the videos and look at the solutions. We're going to try lots of different types of problems that make us go back and forth with different techniques. And then again, remember at the end of this section, we are going to learn one more technique that applies to a new type of scenario.